Okay, so here we've got, hopefully the head's in shot, but here we have our cart set up with our bench pulley, and this bench pulley is tied to a slotted mass weight carrier, and it's done so that the string, when this goes right to the end, the actual slotted mass carrier is still just hanging. That way when you do your acceleration, it doesn't smash against the floor and wreck the equipment. But anyway, here's our masses. Of course, in this experiment, you'll be changing the mass of the cart. Remember that the force going down is constant because you've got the pull of gravity pulling on the mass of the mass that you have here, which doesn't change. So therefore, the force that's applied to the cart in this direction doesn't change. Okay, it's constant, it's a constant force, which is what we want. And we want to change the mass that we place on the cart. All right, we've just got to connect up to the ticker tape, and then we'll take a run. All right, so now we've got it all set up. Remember with the ticker tape that it has to be using AC, not DC. Remember that you need a nice even up and down motion of the ticker tape, just like this, block your ears. And if you don't get that, to just wind the little wing nut so that the metal rod vibrates up and down. Okay, so once you've got that all set, you're going to bring it back here, hold it like so, turn it on, let it go, and you're going to get an acceleration strip with no weights. And of course, you should really mass the car, so you should find out how much the car weighs, okay, by itself, and that'll give you a value, 300 and something grams, let's just say. Then you put the second mass on, new strip, get another acceleration strip, and then you put all the masses on for your last strip, put a new piece of paper through, and then get your last strip. So you end up with 3 strips. You work the acceleration from each strip, put that in your results table, and you should see how, when the force is kept constant, the mass that you are changing as the independent variable goes on the x-axis, and its acceleration, which is what you're recording, goes on the y-axis. All right, let's go ahead and get some data. All right, now that you've got your results, we're going to go through them, and this is a bit of revision because I know that you've watched how to calculate acceleration video multiple times and you're all experts on it, but if you're not, this is just to get your neurons in your cerebrum back into alignment. So remember, you had 3 strips, and you had those 3 strips for each acceleration that you had based upon how much weight you put on your cart. So what I would be expecting to look in your books is that I would have strip 1, so this is the cart only, 350 grams, and then you'd have either a diagram or the actual strip stuck into your book. And you're showing your analysis now of the actual data. And so you measure the first segment here. So my segment, I'm just getting this here. I've got 1, 2, 3, 4 dots. I've put lines next to them. And I've measured the distance on my tape. So the distance between those 4 dots is 1.5 centimeters. So I've got my initial speed. Remember, U stands for initial speed or initial velocity. And it is 0.015 meters. So I've just converted that centimeters to a meter value. And then now the time it takes to do that. So I've got 1, 2, 3, 4 spaces. We know that each space represents 0.02 seconds. So 4 times 0.02 seconds is the time over which I made my measurement. So I put that in there and I get a speed of 0.19 meters per second. So that's my initial speed. I now do the same for my final speed, right? With my drawing on the board, I'm just deciding to use 1, 2 dots. Obviously with your strip, the more you can get, it's going to be better, but I've just done 2. So I've said that this is 9 centimeters here. So my distance is 0.09 meters. I then have 2 dots So therefore it's 2 times 0.02. And when I do that, I get a value of 2.25 meters per second. So you can see just by the values that I've started off with less than 0.2 and I've increased to 2.2. My velocity has increased. In other words, I have accelerated, right? So to do our acceleration, it is our final speed v take away our initial speed. Okay, so our final take away initial. And so our final speed was 2.25. Take away the initial speed. Now, divided by the time it takes to do that. And if you remember here, you have to count the spaces between the dots, right? It's because we're working on average speeds. So the average speed along this distance here, we have to start counting in the middle. We can't start from the beginning because then what we're doing is we're saying, well, the initial speed or time value is 0. We don't want that. We want the time between it. So we do 1, 2, 3, 4, 5, 6, 7 ticks. So this strip for me has 7 ticks. So I do 7 times 0.02. And so it turns out that I have minus 14.7 meters per second squared. So that's the acceleration of my first strip. Now you have to do the same thing for strip 2 and strip 3. Okay, now that you have in your books your 3 strips and your 3 calculations for each strip, now we're going to put it in a table. Okay, so you've shown us how you analyze the strip, how you get your data from the strip, how you do calculations, and now we're going to put it in a table. But see, now you're reaching a level where you don't just draw a table and put numbers in, because we need to see how you got those numbers. What analytical technique did you use? In other words, well, you use some formulas and you use those formulas to calculate the acceleration. And so we can see if you make any errors, right? So you need to put your data analysis in there so we can see how you compute these figures, right? So here's our table. Now just remember, when you do a table, this is a very simple table here. You're starting off from the fundamental concept of tables where the columns are arranged in a certain way. And so generally in science tables, we have the independent variable on the left-hand side and we have the dependent variable on the right-hand side. And so that's what I've got here. I've got the independent variable, which is the mass of the trolley. And here is the mass of the trolley with no weight in it, 350 grams. Please make sure that your units are not in the cells of the table. The units are up in the column. Okay. And then I have my dependent variable, what I'm measuring, and I'm actually measuring the acceleration. That was what the connection was in our aim, to see how the acceleration changes when the mass changes, right? Even though we actually measured the speed, and from that we measured the acceleration. So here's my acceleration. Now, of course, when we do design experiments, and when you design experiments, you want to make sure you repeat them so that you can minimize chances of error. So with this here, when we design it, we could go, well, this will be trial 1, this will be trial 2, this will be trial 3, and then I have an average. Now, of course, I could have done that. I could have collected every single group of results, and I could have put it in here, group 1, group 2, group 3, group 4, etc., and then have an average acceleration. But we're just keeping it simple for the moment for your group's results. So here's the mass of the trolley, here's the acceleration, and you put your other values in there, okay, whatever they turn out to be. Remember that my table has a heading, and all headings have both the dependent and independent variable in there, so I have that there. Now, of course, when you go to graph it, you want to then make sure that your dependent variable is on the y-axis, and so my acceleration is going to be in the y-axis, so acceleration of cart, and my units is meters per second squared. And then down here on my independent variable is the mass of the trolley. And that's in grams, okay? So then you graph your result and you should see a specific graph shape. Now remember, when you're doing your lines of best fit here, your lines of best fit can be due to curved data or they can be straight data. So we're looking at here, and I'll just write it here, and of course it needs a title. Right, and that can be the same title really. And we know that F is equal to ma, and so we're graphing the acceleration A versus the mass of the trolley. And so we should expect an inverse relationship. In other words, as one goes up, the other one goes down. So if we're increasing the mass, you would have known this just by watching the cart, that the cart accelerates slower. So as you increase the mass, the acceleration goes down. So it's an inverse relationship. So we should expect to find a graph that sort of looks like that, right? An inverse relationship. So as the mass increases, the acceleration data decreases. So if I was to look here, let's say the mass of 100, then I was to go up and I was to read a value, I might find I have a high acceleration. Let's just make up some values. Let's say 20 meters per second. But then if I was to go from 100 to 500, so I was to increase the mass, when I go up and read off the graph now, I'm going to get a significantly lower acceleration. So I might get an acceleration of maybe 7 meters per second. So you can see that as I increase the mass, my acceleration decreases. And of course, you will have a line of best fit there to take out any errors. So hopefully that makes sense. It helps you with your data analysis and that. I want you to make sure that for my class at least, that this helps you analyze your data. So next lesson, I should be able to see all your calculations. I should be able to see it tabulated and also graphed. And then we can talk about how we write up a discussion using evidence from our data. All right, see you then.